Okay, so Chapter 9, Rational Expressions. The last section is Section 9.5 on complex rational expressions. What are complex fractions or rational expressions? Well, these fractions have fractions in the numerator and the denominator or both. And so what we're going to do is there's two ways to do it. We can, one, simplify the numerator, get it done, then simplify the denominator, get it done, and then we divide as usual using techniques we already know. The other way is basically simplify by multiplying each term in the expression by the LCD of all of the terms. So we find the LCD of all the different terms, however many there are, multiply each term by it, and then that gets rid of a lot of the fractions, and then we can go ahead and simplify after that using the techniques also that we already know. So what we're going to do is we're going to kind of do this two ways, and hopefully this will all fit on one page so you can kind of see it at one point. And so what we're going to do first is we're going to do the first method is we're going to get the LCD here, simplify the numerator, simplify the denominator, and then after that we're just going to divide. So if we look at the numerator first, the LCD is 5 times 3, which is 15. And so what does that mean? Well, we're going to have to multiply this by 3 over 3 and this by 5 over 5. Okay, so if we do that, we have 9 over 15 minus 5 over 15. And then the denominator, if we want to work along the same way, we're just going to keep doing basically only numerator and only denominator. So here again, we have 5 and 3 is 15. So to get that, we're going to have to multiply this by 3 over 3 and this by 5 over 5. So 3 times 2 is 6 over 15. And then we have plus in this case. And here we have 2 times 5 is 10 over 15. So again, now looking only at the numerator, we have 9 minus 5. Well, that's going to be 4 over 15. So now we've got the single fraction in the numerator, which is what we've done, what we wanted to do. And then what we do is get the single fraction and then the denominator. 6 plus 10 is 16 over 15. And now we can simplify by dividing. So we can rewrite this as 4 fifteenths divided by 16 fifteenths, multiply by the reciprocal and do it that way. Or we can just multiply here by 15 over 16, and whatever we do in the denominator, we also do in the numerator. So if we think about that, what's happened is in the denominator, when we multiplied by the reciprocal, 15 cancels, 16 cancels, and we're left with 1 down here. Now up here, well, here 15 cancels as well. 4 will go in here once, 4 will go in here 4 times. And so what this all breaks down to is we get 1 over 4, and it's all over 1, but anything over 1 is just itself. And so this is just 1/4. Okay. Now, the other way to do this is we can go ahead and rewrite this as 3 over 5 minus 1 over 3 over 2 over 5 plus 2 over 3. And what we want to do is we want to find the LCD of every fraction. So we've got a 5 and a 3, a 5 and a 3. So the LCD is 15. And what this second method says is we're going to multiply every term. So each one of these is a term. We're going to multiply each one of them by 15. Okay, and so what we can do is we can say we're going to multiply the numerator and the denominator by it. And so when we put those in parentheses, what we have to do is we have to multiply here, we have to multiply here, we have to multiply here, and we have to multiply here. And so that's what it means by multiplying by the LCD. Now in this case, it worked out kind of nice because, they were both 3 and 5 and it didn't have any big differences. Now sometimes when we get to these, when we have the rational expressions, there's going to be a bigger difference. So this is to kind of get you started with the fractions with just numbers, and then we can move over to the rational expressions later. Well, if we write this, that's going to be 15 times 3 over 5, then minus 15 times 1 over 3, all over, and now we have 15 times 2 over 5 plus 15 times 2 over 3. And so what I've done, I've just multiplied it out like this, and I've written it here so we can see what we have. Now I can say, okay, well, 5 goes in here once, 5 goes in here 3 times, 3 goes in here once, 3 goes in here 5 times. Here, 3 goes in here once, it goes in here 5 times. 5 goes in here once, it goes in here 3 times. Now, I can simplify. I have 3 times 3 is 9 minus, well, here I just have 5 over, here I have 3 times 2, which is 6, plus 5 times 2 is 10. So here I've got on the numerator 4, and the denominator I've got 16. Well, guess what? We can reduce that again and say, well, 4 goes in here once, 4 goes in here 4 times, and guess what? I've got the same answer this way as I did the other way. Now, in a lot of cases, the second way is going to be a lot easier to do than the first way, especially when we get to those rational expressions. This time, it really looks like the first way is the easier one because, you know, we kind of got to the answer a little bit quicker. But I'm usually probably going to solve it this second way, multiply by the LCD to get rid of all those fractions first with the x's and y's and z's and everything, and then I'll work it down. Again, you can do it both ways. It's up to you to decide which way is easier for you. All right, so here we have something that we're supposed to simplify, and that means to do kind of like what we did here, simplify. And this time we had arithmetic. This time we have, you know, variables plus numbers. And so if I look at this, what do I have? Well, in the numerator, I've just got a minus 2. So that's not hard. Now the denominator, though, I have a fraction and just a variable. So what I have to do is I have to be able to add those together, and to be able to add those two together, what I'm going to have to do is get a common denominator down here. Or what I can do is multiply that whole thing by the common denominator. So if I keep that as 4a minus a, what is the LCD? Well, that's just a, because that's the only denominator I actually have. And so that means I'm going to take a times the numerator. I'm going to take a times the denominator. And so when I do this, I have to multiply both terms. Again, multiply both terms. So a times a squared, a times minus 2, minus 2a. Now here, when I take a times 4 over a, the a's cancel and I just get 4. And then here, a times a is going to be a minus a squared. Okay. Now, what we have to do now is we have to kind of think about this, because, you know, not only do we, you know, see things in backwards order and frontwards order, we can kind of rewrite this. If we see this as a difference of squares, and remember, when we're doing difference of squares, usually it's like x squared minus 9 or x squared minus 4. We don't put the 4 first and the x squared second, or the 9 and then the x. So what I'm going to do is I'm going to factor out a negative 1. And if I do that, that gives me a squared minus 4. Okay, and that just helps me rearrange this denominator. So that's my new denominator, but look at my numerator. What can I do there? Well, if I do anything here, what I can do is I can say, okay, well, I actually have an a in both of those terms, so I can factor out that a, and so that's going to be a times a, and then if I have left over, that's minus 2. Okay. Now I notice I said, well, x squared minus 4 is the difference of squares. Well, that's because that's x plus 2, x minus 2. So really, what we've got now is a times a minus 2 over, and we're going to keep our negative 1 here, and then I'm going to factor that into a minus 2 times a plus, a, not x, a plus 2. And now what I can do is I can simplify and say, okay, well, a minus 2 cancels a minus 2, and this makes my problem much simpler. Now remember, a negative 1 can be here, it can be in the numerator, or it can be out in front. So what I'm going to do is I'm going to rewrite that negative 1 in the numerator, and minus 1 times a all over a plus 2, and that really is just a minus a over a plus 2. And that would be then my final solution. Now again, you know, I could have simplified. I could have gone through and said, okay, well, let's get the common denominator here, and get those added or subtracted, I should say, together, and then multiply by the reciprocal and see what we get from there. And what's going to happen is we're going to get the same answer. So there's several ways to work these. It all depends on what you think is easiest for you. Okay. All right, what I'm going to do on this one, I'm going to look and see, is there anything nice that's LCD? Well, this one, remember, 2 is really 2 over 1. 5 is really 5 over 1. Then we have 4 over x plus 2 and 10 over x plus 2. So my LCD really is just going to be x plus 2. And so what I'm going to do is I'm going to take x plus 2 times, then I'm going to go ahead and write that as 2 over 1 minus 4 over x plus 2. Then all over, and what I did in the numerator, I have to do in the denominator, so I take x plus 2 times, and I have 5 over 1 minus 10 over x plus 2. And again, I'm going to take that whole thing and distribute here and here. So x plus 2 times 2. Well, that's going to give me 2 times x plus 2. I'm not going to multiply it out yet, but I will eventually. And then I have x plus 2 times a minus 4 over x plus 2. Well, those x plus 2's cancel, so I just get a minus 4. Now notice I went from something that had a fraction in it to something with no fractions, and that's the whole key. That's what we want to do, is get rid of sets of fractions, so then we just really have a division instead of a fraction divided by a fraction. All right, so now here I'm going to take that times that, and so that's going to give me 5 times x plus 2. And when I take this times this, those x plus 2's cancel, and I just get a minus 10. Now I can distribute 2x and then plus 4. Then I have minus 4 all over. Here I have 5x plus 10. And then I have minus 10. Well, guess what it looks like? We can do a little bit of canceling. That 4 cancels that 4, that 10 cancels that 10. So now we're left with just this piece right there. And you know what? We can cancel x and x. And so what do we have left over? Just 2 over 5. Okay. Now, it doesn't always work out if you have something like this. It's always going to just become the 2 over 5. But in this case, it did work out nicely that way. And so we got that 2 over 5. All right, so now we have 2 fractions in the numerator, 2 fractions in the denominator. Now maybe this time let's be different and let's not multiply by the LCD on numerator and denominator. Let's simplify the numerator, simplify the denominator, take one fraction divided by the other fraction and work it that way. So in the numerator, I have x plus 1 and x. And so my LCD is x plus 1 times x. And so what do I have to do? Well, I have to take this times x over x, and this times x plus 1 over x plus 1. So my LCD for the numerator is x times x plus 1. All right, so let's multiply this out. And so we have x times x, that's x squared. And then we have minus 1 times x plus 1. Oh, let's just go ahead and do this. Let's just say that's times x over x plus 1, then minus. And then 1 times that's going to be x plus 1 over x times x plus 1. All right. And the denominator, well, guess what? The denominator is the same. And it's going to be x times x plus 1. So we're going to take this side times x plus 1 over x plus 1, and this times x over x. And so we're going to have x squared over x times x plus 1. And then over here, we're going to have plus, and then we have x plus 1 over x times x plus 1. Okay. Now what can we do? Well, now we have the same denominator and we just have to subtract. Now remember, when we subtract, we have to take that negative throughout. So that's going to give me x squared minus x minus 1 over x times x plus 1. Now the denominator, I can just add straight across, and that's x squared plus x plus 1 over x times x plus 1. Okay. Now at this point, I've got a fraction divided by a fraction, so I could rewrite and say this fraction divided by this one, and then that means I'm going to multiply by the reciprocal of this one. Or I can just say, okay, well, I'm just going to multiply by the reciprocal in the numerator and the denominator. And so I have to multiply by x times x plus 1 over x squared plus x plus 1. All right, so now let's cancel things so we can see what we've done. So this cancels this cancels this, and now we've just got a product here. And this product, that cancels that, and now we just have that trinomial divided by that trinomial. Now, can we factor those trinomials? Well, let's see. We have x squared minus x minus 1 over, and then we have x squared plus x plus 1. And so let's see here. Can we get anything out of that? That's going to be x minus 1, x plus 1. That's not going to work, because if we do this, that's going to give us a 0 in the middle, so that's not the way to do it. And that's about the only way we can do that one. And then this one, if we did the same thing, it's x plus 1 times x plus 1, and guess what? That gives us a 2 in the middle, so that doesn't do it. And so this is our final form. It's just one trinomial divided by the other one. Neither one can be factored, and so that's going to be our final answer. All right, so this is one that's kind of nice because we have just one fraction divided by another one, and we can do just like we did here. You know, we just multiplied by the reciprocal in the denominator, and then also in the numerator, and we can then after that start reducing if possible. So if I multiply that by the reciprocal, that's 16ab squared over a plus b. And I have to do that here as well. And so if we look here, those cancel those cancel those. Now we can do a little bit of simplifying here. One of those cancels 4 of those, and then one of those cancels that. One of those cancels one of those. And so now what we can do is we need to rewrite this, because notice that's a difference of squares. We have a squared minus b squared, and then here we just have, it looks like, over a times, and up here we have a 4b over, and then we have a plus b. So that's what we've reduced it to at this point, by just multiplying by the reciprocal. So, you know, this, everything cancels in a denominator, and then we just kind of reduce there. Now, a squared minus b squared, that's a difference of squares. So it's a plus b, a minus b, all over a times 4b over a plus b. And we have one last thing we can cancel then. We can cancel that a plus b over a plus b, and that gives us the final answer of 4b times a minus b all over a. And again, I'm not going to multiply it out. That way I know that it's in the most factored form and I can't reduce any further. All right, so what do we want to do here? Well, we can get LCD for the numerator and simplify it. We can get an LCD for the denominator and simplify it, and then do like we did on the last two, multiply by the reciprocal. Or what we can do is we can say, what is the LCD for this whole thing? Well, remember, this is over 1 and this is over 1. So our LCD is just 3x minus 4. So LCD equals 3x minus 4. And so I'm going to multiply numerator and denominator by that. Because remember, when you multiply by the same thing in numerator and denominator, you're just multiplying by 1. So now I'm going to take, and basically I have to FOIL. And so I'm going to take and FOIL these. So I'm going to have 1 times 3x is 3x. That's my, you know, this times this. Then I have 1 times a minus 4, so it's a minus 4. And then I've got a minus 2x over 3x minus 4. Wait a minute. Yeah, so that's actually what I'm going to do is I'm going to take that whole thing. Sorry, I'm saying things what I'm doing, but not saying what I mean. So I'm going to take this whole thing times each term. Okay, so when I do the first term, that's what I get. And then I'm going to take it times the second term. Those are going to cancel, and I just get minus 2x. That's what we wanted to do, is get rid of that denominator. Now I'm going to do the same thing. Take that whole thing times the first term and the second one. So when I do that, I'll have 3x times x. So that's going to be 3x squared. And then I'll have x times 4. So it's going to be minus 4x. And then when I take it times this one, I'll just get minus 32. So 3x minus x, that's going to be x, and then minus 4. And down here I'll have 3x squared minus 4x minus 32. Okay. Now, the key is, does this actually factor? And maybe that would be one of my terms. So what I'm going to try is x minus 4 and 3x plus 8. And so that's going to be minus 12 plus 8 is going to be minus 4. That's minus 32. That's plus that. And so it does factor that way. And so that's my denominator. So my numerator cancels here. And that gives me in the numerator 1 and the denominator 3x plus 8. Okay, so I took the LCD of the whole thing, multiplied each term by it. So I took that term by it, that term by it, and that term by it, and that term by it. I got this. Then I simplified where I could, which is just taking 3x minus 2x and getting x, then minus 4. Then I had to factor the denominator, then my x minus 4's cancel, and I get the 1 over 3x plus 8. All right. I think I'll do the same thing here. I'm looking and I see a y squared and I see y. So that means my LCD must be y squared. And so I'm going to take y squared times everything in the numerator and everything in the denominator. So when I do that, when I take it times here, I just get 1. Then I have minus y squared. Down here, I get y squared. And then I have here, one of the y's cancel, and I just have y, then plus y, okay? All right, so what do I see here? Well, that looks like since the y squared's in the front here, I can take out a negative 1, and then that's going to give me the y squared up front, and then minus 1, because if I take that, that's a minus y squared plus 1, minus y squared plus 1. So that rearranges it. So then I have a difference of squares with the variable first. And here what I can do is I can pull out a y, and I have y plus 1. Okay. Well, how does that help me? I can factor that. That's y plus 1, y minus 1, all over y times y plus 1. And my y plus 1 cancels. Okay. And so what does that give me? That gives me minus 1 times a y minus 1 over a y. And again, you can rewrite this multiple ways. Maybe you want to write it as y minus 1 over a negative y, or you want to change it to 1 minus y over y. Whatever you want to do, as long as you follow the rules of multiplying by the negative 1, you can put that anywhere you want to. All right, so let's do one last one before I stop and then make another video with additional material. All right, so on this one, we have a b, we have a 2, and we have a b squared minus 1. So this one, I'm not sure what the best way to go about this one maybe is, but maybe we can say, let's simplify the numerator and simplify the denominator. Well, guess what? The denominator is just going to be 4 over b plus 1, b minus 1. Okay, so that's what I've done here. That's a difference of squares, and so I factored that. And so now my LCD up here is going to be 2b. Well, okay, so how do I get that? Well, I have to multiply that by 2 over 2 and that by b over b. And so that gives me 2 and then plus b all over, and then it gives me a 2b. Okay, now I've got one fraction over the other fraction, and so what I can do is I can multiply by the reciprocal. And when I get that done, then I can see if there's anything that cancels. Well, I know those cancel and all that cancels because I wanted to do that to get 1 in the denominator. Now here, there's really not a lot that looks like can be done here. So well, I guess what we have then is, just to rewrite this, now I can rewrite this as a b plus 2 maybe. And then I have, and remember we're multiplying here, and so it's going to be b plus 1, and then b minus 1, and then all over 2 times 4 is 8b. And so that is really what this boils down to as far as when we simplify, that's all we can do here. So it didn't really reduce anything, it just made it into a different form. It's not as complex looking as this one, but it's still, it can't be reduced any further than this. All right, so that's where I'm going to stop, and then I'll do another video with the additional problems from this section.